Welcome to Brain Vision.
To find the magnitude of the acceleration, we have to find the magnitude of the net force that acts on that object. So on this object, there are two forces acting, this one and this one. So the vector sum of these forces is the following. So we have a 60 Newton force, and then we have a 40 Newton force. So this would be the net force, this hypotenuse here. Then this is a rectangle triangle. This side of the triangle has 60, this other side has 40, and here we have the net force. Then, by using the Pythagorean theorem, we get the net force of square root of 40 squared plus 60 squared, which results in approximately 72 newtons. Then we can use Newton's second law to determine what is the acceleration, because Newton's second law tells us that the magnitude of the net force is equal to the mass of the object times the magnitude of the object's acceleration. Then the acceleration is equal to the net force divided by the mass. The net force is approximately 72 newtons and the mass is 4 kilograms. So this gives us an acceleration of 18 meters per second squared. Now we have to determine its direction with respect to the x-axis. So let me draw the net force here in the object. So the net force would be pointing in the diagonal like this, and it makes an angle with the x-axis or the horizontal axis, which is in this direction. That angle I will call theta. So here we have theta. Then we have to determine what is theta. So using the same rectangle triangle that we had used before, we can determine what is the value of theta, because here theta is in this side. So here we have theta. It's the angle in between the hypotenuse and the 40 Newton side. Then we can calculate, for instance, the sine or the cosine or the tangent of theta. I will go with the tangent. So the tangent of theta is given by the opposite side divided by the adjacent side, and this results in 6 divided by 4, or 3 divided by 2, or 1.5. Then theta is the inverse tangent of 1.5, which is approximately 56.3 degrees. Then the direction is 56.3 degrees above the x-axis.